Okay, in this video we're going to learn about symmetry. So a graph is symmetric with respect to the y-axis if the y-axis reflects the graph. And what that means is the y-axis acts like a mirror. So let's have a look, first of all, at some of these. Okay, so all of these graphs are symmetric with respect to the y-axis. If I look at this, if I cover up half of it, and it doesn't matter if it's the left or the right hand side of the y-axis, if the y-axis was a mirror, what would you expect its reflection to be? You'd expect it to be something like that, and that's what you get. And it doesn't matter which side you start with. So this is symmetric with respect to the y-axis. This is symmetric with respect to the y-axis. Here we have a point that's 1, 2, 3, 4 units to the left of the y-axis. And here the point is still 2 below, but it's 4 units to the right. These points are reflected in the y-axis. So if this was looking in the mirror, what would its reflection be? If the y-axis was the mirror, there it would be. So this is 3 units to the right. Its reflection would be 3 units to the left, and so forth. Again, we have to make allowances that I drew this freehand. This figure is symmetric with respect to the y-axis. If this is the y-axis and it's a mirror, we would expect its reflection to look like that on the other side, and it does. This is reflection in the y-axis, this graph. If the y-axis is a mirror and I want to reflect that blue part over there, then it would look like this. Okay. Just for the record, something like this would not be symmetric with respect to the y-axis, would it? Because if the y-axis is the mirror, then the shape I would get in the reflection would be like that, but this is 1 unit to the right, and I would expect its reflection to be 1 unit to the left. And that's not what happens here. So this is not symmetric with respect to the y-axis. It's close, but it's not. Okay. Now, we have something interesting that says an even function is one whose graph is symmetric with respect to the y-axis. So this would be an even function, because it is a function, isn't it? It passes the vertical line test, and it's symmetric with respect to the y-axis. So this is an even function. This is an even function. It's a function, okay? It passes the vertical line test. Nothing, nothing, once, nothing, once. So this is a function. It's symmetric with respect to the y-axis, and so this is also an even function. So both of these are even functions. These graphs, while they are symmetric with respect to the y-axis, they're not functions. So that's not a function, that's not a function. So if your graph is symmetric with respect to the y-axis and it's a function, then we say it's even. Now, what if you get a question like that? Is the graph of this symmetric with respect to the y-axis? Well, we are allowed to use graphing calculators, and so put it in your calculator and then look at it. So let me just clear this. Now, if I'm going to put that in my calculator, I must put parentheses around numerator and denominator if there's more than one term, or you're going to get the wrong picture. So I'm going to put parenthesis x squared plus 3, close parentheses, that's my numerator, divided by parentheses x squared minus 1, close parentheses. Then start out with zoom 6, zoom, and then the number 6. And that should give us a standard viewing window. Now, do the test. Is that symmetric with respect to the y-axis? If the y-axis is a mirror, cover up one side, it doesn't matter which. What would its reflection look like? Well, the reflected part of this should look something like that. And the reflected part of this, if the y-axis is a mirror, should look something like that. And that is what we get. So is the graph of that, you can tell by putting it into your graphing calculator and then making the judgment. So the answer here would be yes. And then in fact, is the function f of x equal x squared plus 3 over x squared minus 1 even, odd, or neither? Well, we've just seen that it would be an even function because this is what the function looks like and it's symmetric with respect to the y-axis. A graph is symmetric with respect to the x-axis if the x-axis behaves like a mirror or a pond and it's reflected in the graph. So the way you can see these is if I draw this part in red, and if the x-axis were a pond or a mirror, what would you expect its reflection to look like? Something like that. Okay, and that's, again, considering that I drew it freehand. If this is my graph, and then this other bit here, does that meet the definition, considering that it's freehand? Well, if the x-axis is a mirror, the blue part's gazing into the mirror of the pond, I'd expect its reflection to look like that. Okay, and same thing here. If the x-axis is a mirror or a pond and that red part's above the pond, I'd expect its reflection to look like blue. Okay, now notice that both of these figures are symmetric with the x-axis, but they are not functions because both of these violate the vertical line test. So if you're just, instead of the two colors to see the reflection, if you're just given that, yes, that is symmetric with respect to the x-axis, but it's not a function. It fails the vertical line test. Same for that one. And finally, a graph is symmetric to the origin. So a graph is symmetric with respect to the origin, a point, that's 0, 0, if when you turn the graph upside down, you get exactly the same graph. Exactly the same graph. Okay. So luckily I have a book so I can do this. Is this graph symmetric with respect to the origin? Well, turn it upside down. And we do. We get exactly the same graph. So this is symmetric with respect to the origin. What about this? Is this graph symmetric with respect to the origin? We'll look at it. And again, take into consideration I did it freehand. What happens if you turn it upside down? You do get the same graph. Okay. So this is symmetric with respect to the origin. What about that? Is that symmetric with respect to the origin? Well, turn it upside down and we do get exactly the same graph. That is symmetric with respect to the origin. WRT with respect to the origin. Is this graph symmetric with respect to the origin? Well, do we get exactly the same graph? No. Be very careful here. We do get exactly the same shape, but we do not get exactly the same graph. So look at where this guy is here. It's right underneath the x-axis, yeah? What happens if I flip it? If it's symmetric with respect to the origin, I should get exactly the same thing over here. And that's not what's happening. So we're getting the same shape, but it's not in the exact same position. It's not the same graph. So this is not symmetric with respect to the origin. A function is called odd if it is symmetric with respect to the origin. So this is an odd function. It's a function and it's symmetric with respect to the origin. This is not a function. The figure is symmetric with respect to the origin, but it's not a function. It doesn't pass the vertical line test. So see here, this vertical line goes through more than one point. It's not a function. That's not symmetric with respect to the origin. What about that? Is that a function? It is a function. It passes the vertical line test. So both of these are odd functions. Neither one of those are an odd function. This is not symmetric with respect to the origin. That is, but it's not a function. So now, if you have questions like the following, so let me try and in the book, take it and manipulate it. Even, odd, or neither. That's odd. If you turn it upside down, you'll get exactly the same thing. Even, odd, or neither. Even. Even, odd, or neither. It's neither one. Even, odd, or neither. That's neither one. Even, odd, or neither. Even, odd, or neither. Okay. Now, what about these? Determine whether they're even, odd, or neither. What do? Put them in your graphing calculator and look at the function. So let's look at that number 44. 2x over absolute value of x. So 2x, I'll put that in parentheses, divided by the absolute value of x. In this older one, you press math, scroll over to Noom, and then press enter. So ABS is absolute value. Then do x, close parenthesis, and then do zoom 6. That looks like an odd function to me, because what happens if I take it and I turn it upside down? I get exactly the same graph. That's an odd function. So I can use my calculator to answer these, and I don't have to do any calculations at all. Okay. So I'm going to stop the video now.